All right, here we go. Today's lesson is all about estimating area using grids. So this lesson, we're not going to make use of a formula to find the area. Instead, we are going to just estimate the area, trying to figure out how many grid squares are occupied by this triangle. I think maybe the most effective way to do something like this is to take a look at how many triangles are completely filled in. Start there. Okay, so if we start there, we've got, this is maybe 1, 2, 3, 4, 5, 6. So for sure, we know there's 6 grid squares completely filled in. So I'm going to write that down. I'm going to say, I could just even write whole, and there's 6 of them. Now, obviously, there's more than that because of those partials. But now what we need to do is try to figure out the partials. Okay? So, let's take a look at that triangle some more. All right? So, we got this guy. This guy is almost definitely half. This guy's half. So together they make 1. Half, 1. So we got these 4 parts that make 2. Okay, so we got 2 so far. Now, what else do we got? Well, let me actually just take put a wee check mark just to show we've used these, because now what we're left with is this stuff over here. And we have to basically try to figure out how many triangles or full grid squares this is going to be. So we've got a little bit here. Now this little bit here could probably go in here. Okay? And this little bit here could probably go in here. So that's to say this guy, and this guy all make another whole. So we're up to 3 from the partials. Now we are left with this guy and this guy. I don't know if it's perfect, but I'd say it's a pretty good estimate that these two add up to give you one last grid square. So altogether, I would say we get, from the partial grid squares, we get 4. So if you add 6 and 4 together, you get 10. So that's it. That's how you do this. You need to look at how many of the grid squares are completely occupied, and then you have to go ahead and try to put the pieces together to make a whole and see how many whole grid squares you get. Okay? All right. Now, we've got a circle. And for the circle here, it tells us 1 square is 1 centimeter squared. And we want to find out what the area of the circle is. Now, taking a look at the circle, how many entire grid squares are filled in? 4, that's right. 1, 2, 3, 4. So we know it's 4. Okay, cool. So if we go over here, we would say whole. There's 4 of them. Okay? Now, we got to figure out how many grid squares the partials are going to add up to. And you know what? This is a little tricky sometimes. Sometimes you got to really try to figure it out, and it's not clear cut. But I guess we could take a look at this. Let's take a look at this. Okay? We've got one almost, another almost, another almost, and another almost. Here's what I'm going to say. I think if we took this piece here and we divided it up, I bet it could give a little bit of itself to fill in that piece, a little bit of itself to fill in that piece, a little bit to fill in that piece. But now that I'm looking at it, I'm a little less sure that it's going to do 4 of them. I think it's probably going to do 3 of them. So I'm just going to give that a wee erase for now. So I think that these 4 pieces are going to probably add up to 3 entire grid squares. Okay? So actually what I'm going to do is I'm just going to back out for a second here. And I'm going to write down 3 for now, just so I don't forget it. Okay? Because I don't want to forget it. Because if I forget it, then all of a sudden I end up with a screwy answer and I'm way off base. I don't want to do that. So now I'm back here, and I can use the same logic again. I'll use different colored check marks, but we have these 3 almosts, and this corner piece is probably going to fill in the gaps on those to give us 3 partial completes again. So I'm going to put another 3 here. Okay, that's another 3. Now what we need to do is figure out what the rest adds up to. Now we take a look at this, and let me try and highlight it, but let me pick a nice color here. Maybe I'll pick maybe a dark color actually wouldn't be a bad idea. All right, so I could take like a little part of this, and that's probably going to fill in the corner there. And I could take another part of this, and that's going to fill it in there. But then I got a little piece left here that I can kind of add on to this. So we have 1, 2 holes, and then we got this. So 2 holes plus this. How much of the whole grid square do you think this is? About. Roughly. How full is that grid square? Roughly.
1/3. 1/3.
Be a bit more than a third. What's a little bit more than a third? No, a fourth is less than a third, actually. What's more than a third? What about half? Let's say it's about half. So we've got 1 hole, plus a half. So that gives us 2.5. And we can plunk that down there. Add those up together. 4 plus 3 plus 3 plus 2.5 is going to be 12.5. And it gave us units. It said that one of these grid squares was 1 centimeter squared. So it's 12.5 centimeters squared. And there we go. That would be a pretty safe estimate for the area of that circle. Okay? So when you do these questions, you're going to have to go ahead and show your work just like we're doing here. It doesn't have to be super fancy or super elaborate, but you do got to show your work. Okay? So the last one we have here, 1 square is a kilometer squared. What's the approximate area of the lake? Now I do see your pictures are pretty dark. I mean, mine are kind of dark here. Just wondering, can you see these lines okay or no? No? What's that? No? Nobody can? Okay, I'm really sorry about that. I'm really sorry about that. The copier near the library is really dark. So you're really going to have to look up here, I suppose, to see how it fits. So here we have 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, 6 holes for sure. There's 6 whole grid squares right there. So we can back out a wee bit here, and we can say that there are 6 grid squares that are wholly in there. Then what we need to do is we need to take the partials and see what we end up with. Okay, so let's take a look. Now, well, what do we got here? I don't know. I guess another way of maybe doing this is like, especially if you're just putting a couple together, I'm going to say call this A. I'm going to call that A. I'm going to call this A here too. I think together they probably make 1 hole or close to it. Maybe not right on the nose, but I'd say that's 1 hole. And then I don't have to rush and put it over there because at the end we can just kind of figure out what we got left. What else do we got here? I suppose if I did something like, what's that? Bottom right corner. Are you asking about this right here? Okay, so what do you want to combine this with?
The one you marked A above.
Okay. I don't know that we need to even do that because I think A and A together make 1. But we still have lots of stuff to combine it with.
I mean, like above that A. Like,
Oh, here.
that's good. Yeah.
Okay, sure. I don't think together they would make a whole, but we could put them together and we'll let them be B's. Now, I think we're close. Like, I think if we went ahead and did that, we would be somewhere around, I don't know, like about here. We would need something that was about this big. This big. Well, actually, I suppose we could even probably put this in there, and then together they would probably make that whole. So I'll put a B here, and now we've got another whole object, and we're left with a fewer pieces to work with, which is nice. What we can then do is maybe there's kind of a gimme here. If you put this little itty bitty piece up here and you put it over here, I think that those two could come together to make an entire grid square.
The second bottom, the second left box, yeah, there's the above.
Sure. Yeah. If we put this one with the one above it, that would probably make an entire one right there. So we've got another, and because we're going in the alphabet, it's pretty clear to keep track of it. We've got A's, B's, C's, and D's, so that means we've got 4 entire grid squares added on. But the party's not quite done yet. We still have some partial pieces to look at here. I kind of want to focus on this chunk right here. I think if we focus on this chunk here, no, maybe I don't want to focus on that chunk there. I actually want to do this. I want to take this piece here, this E, this piece here, which is just a little bit, and actually this piece here. I think the three of them probably come together to give you another whole. And that only leaves us with two pieces left. And for all intents and purposes, like, it's not a perfect match, but I think we could probably say that these two pieces here come together to make a whole as well, Draven. So we got all the way to F. A, B, C, D, E, F. Of course, that's 6 letters in the alphabet, which means that we've got 6 partial pieces here. So if we go over here, and if you get a slightly different answer than me, that's okay. Slightly different's okay. You can look at it a bit different, and you're not going to get penalized for that. Now, if you're way off, that's a different story. And you should never, and I mean, I understand that the copying job on your lesson is crap, so, but when you get your homework on this stuff, I hope it shouldn't be, and if it is, I'll reprint it right away, but you should never get the whole grid squares wrong. That should always be right. There's a little bit more interpretation when you're working with the partials. So if we have 6 whole and 6 that are made whole with partials, altogether that adds up to be 12 kilometers squared.